I'm just going to do some rapid fire carbon counting without any heteroatoms to start, and hopefully that will get you more comfortable with identifying carbon atoms in a line drawing. And then I'll add in the um, heteroatoms. And I'm also just using the organic chemistry as a second language. Honestly, great resource, but having them drawn out could probably be helpful. So I'm just going to start with this guy. How many, how many carbon atoms are in it? Well, whenever there is an end of a line, that's a carbon atom. And also whenever there's a corner, that's a carbon atom. So here we've got 1, 2, 3, 4, 5 carbons. All right. How about if we have some guy that's like this? All right. Well, the ends of the lines all get a carbon atom, and then any corners get a carbon atom. And I think one thing I noticed on that problem from Alex is that you can't forget the junction where, like, this guy branches off. So, oops, that's 1, 2, 3, 4, 5, 6. So that's 6 carbons. Okay, what about a weird, funky, like, ring like this? I'm not very good at drawing rings, but we'll start up here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 carbons. And what about a ring with a little guy hanging off of it? 1, 2, 3. Oops. Now, did you see what I did there? I started counting by saying 1. Well, that's not actually true. Just a line is actually 1, 2 carbons. And Dr. Ray told us to be careful about that. So when you're counting carbons, you start with 1 as soon as your pen hits the paper. So I'll draw the molecule first. Okay, so 1, 2, 3, 4, 5, 6, and then a 7th one because it's the end of the line right there. So now when we add in heteroatoms, we don't count a carbon there. So I'm going to draw this guy. And he'll have a double bond to an O right here. So the carbons here, I put my pencil down. 1, 2, 3, 4, 5. That's 5 carbons. And I ignored this whole guy because this one has a heteroatom on it, so I don't count a carbon there. So I'll draw a few more. Okay, so here I'm not counting this heteroatom, so I'm going to start counting at this spot instead because that's the closest corner. So 1, 2, 3, 4, 5, 6, 7. So that has 7 carbon. Oh, don't listen to me. See, I did it. This is not counting. I shouldn't have counted that. I made a mistake. So I'm going to start over. And the reason that that was wrong was because this line is like going into the heteroatom. And so even though it's the end of the line, it's attached to this heteroatom, and so it doesn't have a carbon. So the correct answer would be to start here. 1, 2, 3, 4, 5, 6. So that's 6 carbons. All right. Now how about some more heteroatoms? And one more for good measure. Okay, up here, I'm not starting with these guys because they're heteroatoms. So the only carbons in this molecule over here is 1, 2, 3, 4. 4 carbons. And over here, I'm not going to count anything that's connected to this heteroatom. So I end up with 1, 2, 3, 4, 5, 6. 6 carbons. So in terms of the Alex problem that you were working on, that looks like this. OH, OH. Sometimes I'll even draw a little circle around the heteroatoms to remind me that the end of the line, this is like the no carbon zone, and I shouldn't go into it and count it. So in this case, I start up here 1, 2, 3, 4, and I end right here at this 4th carbon because even though it's the end of the line, it's attached to a heteroatom, and thus I don't want to include it in my count of carbons. So hopefully maybe drawing them helped a little bit. And then in the next one, I'm going to talk about the hydrogen counting.